Well, children, a pleasant day to each one of you. Today we are going to learn about changes around us. Now let's begin with the introduction. Human beings are born as babies and with time they grow into adults. Seeds change to become small plants and then become large trees. We grow and increase in weight and size. Flowers blossom, day changes to night, and night changes to day. Cooking of food, rusting of iron, movement of things, stars, planets, and changes in weather are some examples of changes that take place around us. Many of these changes take place on their own, whereas many of them are brought about by human beings. We will study these changes after classifying them into different groups according to their similarities, so that we can understand them in a better way. Okay, now this is going to be a superb lesson, as we are going to see the changes. The best part I like about this part over here is the seed change to become small plants, I guess, and the flowers blossoming, and the day changing into night and the night changing into day. So very beautiful. That's nature. Okay, now keeping this in mind, let's all believe that we are going to have a lovely time together as we go through this lesson. Types of changes. Changes taking place around us can be of two types: reversible changes and irreversible changes. Changes which can be reversed back to the initial state are called reversible changes, and the changes which cannot be reversed back to the initial state are called irreversible changes. Squeezing of a rubber ball, freezing of water to ice, melting of wax, evaporation of water, and melting of chocolate are a few examples of reversible changes. In all these changes, the internal structure of the substance does not change, and therefore the substance can be reversed to the initial state. See, here you can see the melting of the ice. Okay, this is when it is this water, this is when it is cooled, and then again it changes to water, and this is what happens when it is heated. Okay, so now this is also interesting. All right, the cooking of food, growing of plants and animals, ripening of fruits, and blossoming of flowers are irreversible changes, as these changes cannot be reversed. In all these changes, the internal structures of the substances change as the molecules react with each other to form new substances. Changes which take place around us can be classified into two types, depending upon whether a new substance is formed during the change or not. See, this is the ripening of fruit. Beautiful, isn't it? You sit and you surf the net and see as to how the ripening of fruit happens. You will, let me tell you that you are going to have a wonderful time, children, looking at that view. Okay, now let's see the activity number 1. Make a list of changes which take place around you on the basis of the time they take to happen. For example, changes which take place daily, in a few days, and which can take place in years. Now do this list on your own and show it to me. Then we come to physical changes. The change in which no new substance is formed and the substance only undergoes a change in its shape, size, appearance or state is known as a physical change. In all these changes, internally, the substance remains the same before and after the change. Therefore, all these changes are temporary. By reversing the process, the original substance can be obtained. Here are some examples of such changes. Freezing of water. Water can be easily frozen into ice. Internally, the molecules of water remain the same. Only its state changes when it becomes a solid from a liquid. Then tearing a paper. Tearing a paper changes its shape and size, but the molecules of paper remain the same. Dissolving a solid in water. Dissolving sugar or salt in water is an example of a physical change, as sugar or salt breaks down into its molecules. These molecules go inside an intermolecular spaces of water and therefore disappear. These solids can be recovered from water and therefore this process is a reversible process. Now coming to condensation and evaporation. The process of converting vapors into a liquid is called condensation. The process of converting liquid to vapors is called evaporation. Now wool knitted to sweater. Knitting sweaters or any other woolen clothes from wool is a physical change and the wool can be recovered from it. Did you get it, children? Now these were some interesting facts. Okay, now this is dissolving salt in water. This is knitting. This is unraveling the wool. Like if you don't like it, how you can open it off. Okay, now and how you can open it and recover it. Now here is the chemical change we are going to see now. The changes in which new substances are formed possessing the properties that are different from the original substances are called chemical changes. In all these changes, new types of molecules are formed from the combination of the molecules of the original substances. Mostly, chemical changes are irreversible changes as the new substances formed have different properties than the original substances. Here are some examples of such changes. Cooking food. Cooking vegetables, rice, pulses and making chapatis or breads from wheat flour are all chemical changes in which new substances are formed with different new properties. Similarly, once you boil an egg, you cannot change it back to the raw stage, can you? Chapatis are prepared from dough. Now you can't make it back into the flour, can you? So these are all chemical changes which take place on cooking of food. Okay, then let's come to the burning of paper, wood and other fuels. Burning of paper, wood and other fuels like petrol, diesel, kerosene, etc. are all chemical changes as new substances are formed in these changes. For example, during these changes, ashes are formed which are irreversible. Okay, now this is burning of paper. Ashes form. Can we do anything? Can we reverse it? Definitely not. Now rusting of iron. When iron comes in contact with air and water, it changes to brown colored substance called rust. The process of forming rust on iron is called rusting. Now this is rusting here, children. Rusting eats up the iron and it cannot be reversed. So it is an irreversible chemical process. Now conversion of milk to cottage cheese. Cottage cheese or paneer is made from milk by adding lime juice to the milk. This is a chemical change as milk cannot be recovered from the cottage cheese or paneer. This is milk and this is cottage cheese. We cannot get the cottage cheese back to become milk. Okay, now what is it in, do you know? The process of forming new types of molecules by chemical changes is called chemical reaction. The original molecules taken are called reactants, and the new molecules formed are called products. Okay? Now, activity number 2, classify these changes as reversible or irreversible changes and physical or chemical changes. Now, this is over here it is written, that's water to steam, ice to water, dough to rotis or bread, ironing cloth, quick lime to slake lime, cooking food, rusting of iron and milk to curd. Now this is what you are going to do it on your own, whether it's reversible or irreversible and whether it's a physical or a chemical change, and you're going to get back to me. Okay? Now let's see what this do you know has in store for us. Cakes are made fluffy by adding yeast or sodium bicarbonate to the cake batter. When the batter is heated, the yeast or sodium bicarbonate releases carbon dioxide which escapes and makes the cake soft and light. We all love cakes, isn't it? So this is what actually happens when making a cake. Okay, how is it made fluffy? By adding yeast or sodium bicarbonate. Okay, the yeast and sodium bicarbonate releases carbon dioxide which escapes and makes the cake soft and light, and we enjoy eating it, isn't it? Now to the checkpoint, children, you're going to go through the lesson and you're going to solve it on your own and you're going to show it to me. Now let's see to the factors affecting changes. Changes whether physical or chemical happen under following conditions. That is on heating. Heating is the most important condition required for change to take place. Melting of ice, evaporation of water, cooking of food, burning of paper or wood, etc. are both physical and chemical changes which take place only when the original substances are heated. Mixing solutions of different substances. Mixing solution of different substances may result in the formation of new substances or chemical changes. Passing electricity. This is passing of electricity. Passing electricity to some substances causes them to change. For example, when electricity is passed through water, it breaks down to hydrogen and oxygen gas. Now, water to hydrogen gas plus oxygen gas. Okay? You can see here O2 and H2. Okay? Now, adding of water. Adding of water to some substances lead to physical changes, and in some substances it leads to chemical changes. For example, addition of water to flour causes physical change and forms dough for making chapatis. Got it, children? Now then we go to the changes due to heat. Every change that takes place around us involves energy. Energy is needed for some simple activities like tearing paper, cooking food and drying clothes. At times, energy is given out when a change occurs. For example, when paper, wood and fuels like petrol and diesel burn, light and heat energy are released. Energy is released when steam condenses to water or water freezes to ice. Now, James Prescott Joule, 1818 to 1819. James Prescott Joule was an English physicist and brewer, born in Lancashire. A son of a wealthy brewer, Joule managed his business and conducted scientific experiments as a hobby. We all know what is a hobby, ain't it, children? He studied heat and its relationship with energy. The unit of energy, joule, is named after him. Now, I want you to start doing a research on James Prescott Joule and everything about him and make a mini booklet on him. Okay, now changes due to expansion and contraction. Some substances like iron expand or grow in size when heated and contract or become smaller or shorter when they are cooled. You will notice on a railway track, small gaps are deliberately left between the rail ends to allow expansion of rails in hot weather. These are known as expansion joints. See, are the expansion joints. In winter season or when the temperature is low, the tracks contract and come back. Okay. Now we move to solubility and factors affecting it. The homogeneous mixture of two or more substances is called a solution. In the solution of water and sugar, water is called solvent. Solvent is a substance in which the other substance is added. The sugar which is added to the water is called a solute. Only a certain amount of solute can be added or dissolved in a solvent. If we keep on adding solute to a solvent, a stage comes when no more solute will be soluble in it. At this stage, the solution is called a saturated solution. Did you get it? At which stage does it is called a saturated solution? When no more solute will be soluble in it. Okay. The maximum amount of solute that can be dissolved in 100 milliliters of solvent at room temperature is called the solubility of that substance. The solubility of solutes depends on the temperature. Generally, solubility increases with an increase in temperature. It happens as the intermolecular spaces between the molecules of the solvent also increase on heating. Therefore, more solute can be dissolved in the solvent when the solvent or the mixture is heated. The solubility of sugar and other solutes in water increases with an increase in temperature. Every solute has its own solubility. For example, the solubility of sugar in water is more than the solubility of salt in water. Also, with the increase in the amount of water, the solubility of sugar rises rapidly, whereas the solubility of sugar increases very, very slowly. Many other types of solutes can also be dissolved in water, like lemon juice and some gases like oxygen. The solubility of gases in water is the least. Okay, now water is a universal solvent. Water can dissolve a large number of substances in it. That is why it is called as a universal solvent. Rivers carry vast amount of minerals dissolved in water from one place to another. We need water to digest our food. During digestion, food can be reduced to simple substances that are soluble in water and are absorbed in the body in a soluble form. Plants absorb nutrients from the soil through water. Minerals from the roots of plants and food from their leaves are transported to the other parts of the plant in the form of solutions in water. Now, do you know? Let's see what does do you know have in store for us. Water has a unique property. It expands on freezing. When it freezes, its molecules arrange in the proper order, due to which its volume increases on solidification and hence its density decreases. As a result, ice has a lower density than water and floats in water. That is why icebergs float in water. Beautiful, isn't it? Now, children, I want you to surf the net and learn in depth about the iceberg floating in water. I'm sure you're going to have a gala time there. Okay, now checkpoint. We will discuss in class and then it's up to you. You have to do it on your own. Okay, now let's see about the points to remember. Changes which can be reversed to the initial state are called reversible changes. Changes which cannot be reversed to the initial state are called irreversible changes. Changes with no new substance is formed. and the substance only undergoes a change in its shape, size, appearance, or state is known as physical change. The change in which new substances are formed with properties that are different from the original substance is known as chemical change. All chemical changes are irreversible changes. Every change that takes place involves energy. Water is a universal solvent. Now, important definitions: reversible change, a change which can be reversed back to the original state. Irreversible change, a change which cannot be reversed back to the original state. What is a physical change? A change in which no new substance is formed and the substance only undergoes a change in its shape, size, appearance, or state. What is a chemical change? The change in which new substances are formed with properties that are different from the original substance. What is a solute? The substance which is added to a liquid. What is a solvent? The liquid to which substances are added. What is a solution? The homogeneous mixture of two or more substances. What is solubility? The maximum amount of substance that can be dissolved in 100 milliliters of a liquid at room temperature. And what is saturated solution? The solution in which no more solute can be dissolved at a given temperature. Now children, I hope you had a gala time and have fun doing this lesson with you. I had fun doing this lesson with you, and you too have fun enjoying this lesson. Okay, have a nice day.